Good morning, afternoon, or evening, everybody. Welcome to the Discover and Access Landsat Analysis Ready Data, or ARD data, from the USGS archive. This is your host, Jennifer Brennan. While everybody is logging in, we have two optional polls at the bottom left and middle portion of your page, and I'd like to thank all of you in advance for your feedback on these polls. It's 2 p.m. Eastern Daylight Savings Time, so we are going to go ahead and get started. What I'd like to do first is just review a few logistics related to this webinar. To ensure the best audio experience, the conference has been placed in silent mode. However, if you have any issues or you have any questions, what I'd like for you to do is enter those into the Q&A pod, and you'll find that located on the lower right-hand side of your screen. This works like a chat. Today's webinar is being recorded. The recording will be posted both to our online Adobe Connect webinar catalog and to both the USGS YouTube and NASA Earth Data YouTube channel within a few days of completion. I will send an email to all registrants with links to the recordings. In addition, today's presentation files will be available for your download at the end of the webinar. As far as timing is concerned, today's webinar is similar to our other Earth Data webinars. It'll be 1 hour long. We've allocated 45 minutes to the presentation and an additional 15 minutes for the question and answer period. Once our speaker has finished his presentation today, what we'll do next is we'll transition to an optional final set of polling questions. And then from there, we'll move directly to the Q&A period. And then just one final note, depending upon the volume of questions that are received, we will extend the Q&A period an additional 15 minutes to 3:15 p.m. for those of you who may wish to stay on the line. What I'll do next is I'd like to pull up today's agenda. I should pull up here in just a moment. During the first 5 minutes or so, our speaker will provide an overview of the Landsat program. From there, we will cover Landsat Collection 1 data products, and then after this, we'll dive into an overview of the Landsat ARD products and how to discover and access these data. The final few minutes will be spent on Landsat Science Products, and our speaker will provide a status update for the Landsat 9 mission. With that, it is my pleasure to introduce today's speaker, Chris Barnes, who is the Landsat Science Communications Team Lead at the USGS. Chris?
Thank you very much, Jennifer. I'll just set up my screen sharing here. I just want to confirm that you can see my screen.
Yes, I can.
Excellent. We'll get started here today then. So just as Jennifer said, this is a quick agenda of what we'll be talking to this afternoon. A quick overview of the Landsat program. Dive into a little bit of what's now called Landsat Collection 1, how the USGS have arranged their archive infrastructure. Talk about the new Landsat Analysis Ready Data product that was just released late last year, and then go into some Landsat Science Products, which have been generated in the works by the USGS for some time, and should be made available publicly towards the end of this year and into the start of 2019. And then we'll wrap up with a quick development status of what's happening with Landsat 9. So those not familiar with the Landsat program, it's been observing the Earth since 1972 with the launch of Landsat 1. Since then, we have had 8 satellite launches. Unfortunately, Landsat 6 failed to maintain orbit in October of 1993, but we still do have Landsat 7 and Landsat 8 orbiting the Earth, collecting imagery every single day. And as you can see from this graphic, we have been able to observe the Earth with an unbroken record since 1972, and this is unprecedented for Earth observation satellites. There are no other satellites that we have that have been orbiting the Earth this frequently with this type of moderate resolution imagery that's freely available to not only everyone in the USGS, but also around the world. So Landsat orbits the Earth in a sun-synchronous orbit, collecting the daylight part of the Earth, and every 99 minutes. And it completes about 14 swaths a day for the entire Earth. So it goes from the North Pole to the South Pole and collects data in a 115-mile swath. And like I said, it takes about 14 of these swaths to complete the entire Earth coverage. So what does that end up being then? As this graphic illustrates, it takes about a 16-day cycle of that to get complete Earth coverage. In June of last year, the archive reached a milestone by surpassing 7 million scenes that have been acquired by the Landsat program since Landsat 1 was first launched in 1972. And this is an example of a representative scene from the 7 million swath that was collected back in June. And this is a picture over in Alaska, northeast Alaska. The lower left portion of the screen, we have some cloud cover that's over the Franklin Mountains of the Brooks Range. And then to the north there, you see some sea ice on top of the Beaufort Sea. Today, the USGS Landsat archive contains about 7.8 million scenes that are freely available to the public and download at no charge. There's about 1,200 scenes a day we continue to add to the archive that are collected between Landsat 7 and Landsat 8, which are still in orbit. So just a little bit about the product. The standard USGS product for Landsat is called Landsat Level 1. So Landsat is classified as a moderate resolution satellite. So of the 7 satellites that we've orbited, Landsat 1 through 5 had an instrument on board called a multispectral scanner. This collected information of the Earth's surface in 60-meter pixels. We call that resolution, similar to your digital camera or how your phone collects pictures. Landsat 4 and 5 had a bit of a more enhanced instrument called the thematic mapper, and that collected data in the 30-meter pixel range, we call it. Subsequent launches of Landsat 7 and 8 now continue to collect data in the 30-meter pixel era. Landsat 8 has an additional instrument on board called the TIRS sensor, thermal infrared sensor, and that collects data in the 100-meter pixel range. So we call this Level 1 the standard USGS output product. It's radiometrically and geometrically corrected, and it contains all bands, quality assessment information, as well as metadata. So users are able to use this information to determine if the scene is useful for their daily application. The output file is in a GeoTIFF file format, which is georeferenced. And the standard projection is called UTM, Universe Transverse Mercator, for most scenes, except those that are above 63 degrees, which have the polar stereographic projection. And the datum is the WGS 84. So from that introduction, we'll now switch to Landsat Collection 1. In 2016, the USGS reorganized the archive into this collection-based structure. Prior to this, the archive was organized in a slightly different way. So what does this mean? It's a major shift in how the Landsat Level 1 product was inventoried. Every Landsat 1 through 8 scene is assigned a tier. And these tiers are real-time, Tier 1, and Tier 2. And I'll go into a few more details in a couple of slides to define what these tiers really mean. And basically what happens, each tier designates a scene's radiometric and geometric suitability for looking at time series analysis and data stacking. So it goes back to my first slide of Landsat orbiting the Earth since 1972 and collecting data. We have this unprecedented collection of data of the Earth going back 46 years. So being able to have systematic radiometric and geometrically corrected data, we can use any, doesn't matter what type of instrument is collected, we can use any scene and stack that over time and look at global change. There were some additional changes that were provided when Landsat Collection 1 was rolled out. This included some metadata changes and also some additions to complement the data. And there were some additional supporting files that were included in the Level 1 product that were never previously provided. Most recently, Landsat 1 through 5, the MSS data completed ingest into the Landsat Collection 1 inventory structure. It took some time as there were some challenges dealing with 60-meter pixel resolutions data as opposed to the 30 meters. And Landsat Collection 1 is the highest quality of inventory of Landsat Level 1 products ever created. The USGS did a lot of hard work in developing this collection infrastructure, and is going to definitely be setting the future for how Landsat data is delivered. So just a little bit of background of the processing levels for the Landsat Level 1 product. There are 3 standard processing levels. So the first one is the most accurate. It's called the Terrain and Precision Correction level, denoted by L1TP. And the reason why I put this slide up is because in a couple of more slides, I'll illustrate what the file name looks like for downloading a Landsat scene. And these are included in there to help users identify what type of processing level has been applied to that scene. So L1TP is the most accurate. It has ground control points and uses DAM, digital elevation models. The next level of processing is called Systematic Terrain Correction, Level 1, L1GT. That just uses DEM data and then payload correction data from on board the spacecraft. And there are no ground control points used in those. And then the final processing level is Systematic Correction, denoted by L1GS. That just uses payload correction data from the spacecraft to geometrically correct the data. So moving on into the collection tier categories. Real-time tier is a temporary designated tier. So the scenes that are immediately collected from the spacecraft are downloaded to the ground stations around the world. And these are put into the real-time tier bucket is what we call them. And these use predicted calibration and validation parameters are applied to these data to make them instantly usable to users within hours of being downloaded to the ground station and available through the USGS archive. And these are suitable for emergency response situations. So rather than wait for approximately 14 to 26 days for the scene to have the calibration and validation files applied to the data, these files are made immediately to users to download very, very quickly. So once the calibration files have been applied to the data, they're bucketed into one of 2 categories, or tiers. Tier 1 is the highest quality. So that's all level 1 TP scenes, from the previous slide, terrain and precision corrected scenes, that have a root mean square error of less than or equal to 12 meters, and that applies to Landsats 1 through 8. And about 90% of all Collection 1 scenes are within this threshold of 12 meters RMSE. And again, the suitability is for doing this time series analysis and stacking data over time to look at global change. And the Tier 2 category basically catches anything that does not go into the Tier 1 category. These are scenes that may not be able to meet Tier 1 parameters due to cloud cover or insufficient ground control points. So this is what a Collection 1 product ID is, or sometimes people call it a file name. So when you download or go and search for a Landsat scene to download, this is what the file name looks like. We call it a product ID. It's very similar to what the scene ID looked like before collections rolled out, but we did add at least 4 new additional fields that you can see here on the screen. So apart from denoting what the sensor was used to collect it and the satellite, we also add the processing correction level. So it's those 3 levels that I showed you earlier, whether it's an L1TP, L1GT, or an L1GS. Some users find that useful depending on their application. We still include the path and row in the product ID name, and also the acquisition year, or the acquisition date of actually when that scene was acquired. We have now added to that the processing year of when that scene was processed, and we also append what collection number that scene or that product is synonymous with. So right now we're in Collection 1 era, so the field will be noted by 01. If there is a Collection 2 and Collection 3 and so on, then that's what that number will increase to. And then we also add what the collection tier category is. So the 3 tiers we have are the RT, real-time, Tier 1, and Tier 2. So for example, here's just 3 Collection 1 product IDs. I've denoted the additional fields that have been added in the Collection 1 inventory structure. So we've added so we can see it was a first one on the top line there is a Landsat 8 OLE image. It had L1GT processing to it. It was path 29, row 30. It was acquired on the 9th of December of 2015, and it was processed on the 31st of January 2016, and it's part of Collection 1, and it was a real-time tier. And you can see that's kind of how we can crosswalk that as well for the other two file examples below. So what other additional improvements came along with Collection 1? We've now added quality assessment bands. This is new for Landsats 1 through 7. We did not have that before with the standard Level 1 product. It has been updated for Landsat 8. And these three examples show you the quality assessment bands for each respective satellite. These are available on the Landsat missions website for you to be able to see in more detail, and I'll have that URL at the end of the slideshow. And we also include the per pixel angle coefficient. This is new for all sensors. This was never previously provided with the standard Level 1 product. Some advanced users like to use this information depending on what their application use is with Landsat data. We've also included some enhanced metadata. We include saturation bit fields. This is new for all sensors. This identifies why the sensor may have saturated, if it was due to clouds, if there was snow and ice, if there was white sand, if the soil was barren. Reflective surfaces like this can oversaturate the sensor, and therefore we identify that in the metadata. We also include the land cloud cover assessment. This provides an estimate of the percent of the land in a scene that was covered by clouds. There's also a cloud cover algorithm. The C function of mask, or CF mask, this is now consistent across all sensors. Again, this identifies where there was fill in the scene or no data, whether there was cloud present, what the confidence of that cloud is in the scene, and if there's any cloud shadow, and also some snow ice, which can be difficult to delineate between cloud. And for Landsat 8, with a thermal infrared sensor that spacecraft has on board, there was an issue with some stray light getting into that sensor post-launch and when it was on orbit. So the great minds of the Rochester Institute of Technology have developed a stray light correction algorithm, which has been applied to these data. So that is no longer an issue for users who use data from the TIRS instrument. So what is the Collection 1 archive status as of today? Here's the breakdown. There's about 1.2 million scenes of Landsat 8, 2.4 of Landsat 7. Both of those spacecraft are still on orbit, so we're adding to that every day. Between Landsat 7 and Landsat 8, we're acquiring around 1,200 scenes a day into the archive. And Landsat 4 through 5, obviously no longer flying, but they contribute about 2.8 million scenes to the archive. And most recently, we added the Landsat 1 through 5 MSS era into Collection 1, and that boosted the Collection 1 inventory up to about 1.3 million scenes. And the USGS strongly encourages users to use Landsat Collection 1 data in use of all their applications. Some of you may be aware there's a data set still out there called pre-collection. This obviously precedes the era of when the USGS released the collection inventory structure. So switching gears to US Landsat Analysis Ready Data. ARD, as we like to refer it to here at USGS, was released in October of 2017 and is one of the newest products to come out from the Landsat program by the USGS. So what is ARD? It's consistently processed Level 1 data, so what I just described to you in the previous slides, for direct use in science applications. So what does that do? It basically reduces the burden of processing large amounts of data for looking at this time series analysis. Again, it goes back to that unbroken archive of Earth observation going back to 1972. So Landsat Analysis Ready Data today is only available for the US. We do get questions if this is going to be applied globally, and you'll be happy to know that the USGS is in the works for making plans to generate global ARD. There's no definite date on when that will be available right now, but you can monitor our social media feed and the Landsat website to learn more information when we hear about that we can communicate to the public. So what goes into ARD? All Landsat 4 through 8, Collection 1, Level 1, Tier 1 products. Those are the inputs that go into able to generate these ARD tiles, we call them. We are asked if MSS, now it's been ingested into Collection 1, will be included in ARD. That's TBD, just because we've only recently completed that ingest of MSS into Collection 1. There's probably going to have to be more analysis of making that suitable in order for it to meet the ARD requirements to do the data stacking over time. So the difference between a Landsat Level 1 patch row scene and the ARD Tile Grid, Landsat ARD, is illustrated in this slide. So most of you that are familiar with the Landsat product, we have the standard Landsat patch row here outlined on the image. And then the white box denotes what a Landsat ARD tile looks like in comparison to the what we call patch row, WRS patch row. So an ARD tile includes all valid imagery that is acquired in a given day within the extent of that tile. And the ARD tile volume might not be always the same because of that. So what comes with Landsat Analysis Ready Data? There are 4 products that users can download so far. And these are called top of atmosphere reflectance, surface reflectance, top of atmosphere brightness temperature, and then the pixel quality assessment. And then there are several other pixel quality assessment products that are available with the download that users will be able to see once they acquire the product. And I won't go into information of those right now because some are used by advanced users, but most people want to know if there is pixel quality assessment information available for the scenes that's comparable to the scenes that they've downloaded. And users will be grateful that there is. So ARD is packaged into those bundles. So we have top of atmosphere, surface reflectance, and brightness temperature, and then the QA. And these are delivered as tar files. And we also include XML metadata. So users may want to search the metadata to see how the product was generated, what was processed in it, and what, most importantly, what scenes went into generating that specific tile. And the product and the file product sizes and the file sizes vary greatly due to what type of product you download, if it's top of atmosphere reflectance, surface reflectance, or brightness temperature, where that tile is located, and also the input data volume in the scene. So people now ask what the file size difference is between the standard level 1 scene and the ARD tile. So this is a table that we posted on our website just to give people a representative example of what they would expect an ARD tile file size to look like. And as you can see from this table, that the surface reflectance file is the largest of all the files that you can download. But these are just rough estimates that can vary greatly, as you can see, from the minimum and maximum range. But these are just a rough idea in case users are trying to plan for storage. If they're trying to download large volumes of data, this kind of gives them an idea of a rough estimate of what a tile size would be for the product that they want to download. So where can you access Landsat ARD from? One of the first stops, believe it or not, is NASA Earth Data Exchange. We're very pleased that they recently ingested Landsat ARD into their data repository. And this is what it would look like when you load it up. You refine by date. You can do a polygon, do a rectangle search, point, upload a KML file, or do some grid coordinates. So it'll display, depending on what your search parameters are, it will provide the grid overlay in the display here. And then you can just simply click on an ARD tile. It gives you a preview of what that tile looks like, so you don't have to download it to see if it's not suitable, if it's covered in cloud. And you can choose to either download the NASA Earth Data service calls these granules. We call them tiles, not a big deal. But you can choose to download a tile or a granule singularly or in multiple granules. So if you just want to download a single tile, that will fire you off to Earth Explorer, which is the USGS data depository. Or if you want to download multiple tiles, you are required to just have an Earth Data login. You do need a login for Earth Explorer as well, so it's not a big hindrance. So an example of how you can access ARD through the USGS. This is our Earth Explorer data interface. You'll find ARD in the drop-down menu from the Landsat dataset, which is listed on the left-hand side, and then blown up for simplicity for you to be able to see what it looks like. And you can also refine by similar parameters. You can do coordinate search, do a predefined area. You can just select a location on the map, only available for the US, mind. Or you can have a range of dates. So once you do that, a search will be returned in the view area, and I've just blown it up on the left-hand side of the screen. Then you have a few options of doing a footprint or doing a browse overlay, similar to what you can do in Earth data, to see if there's too much cloud or if that scene is suitable for your use. You can also look at the metadata, and then also there's an option to select for downloading, and then you can get the option what type of product that you would like to download. So as of right now, this is kind of what I call analysis-ready data in numbers, because it really is a vast data set, which is very, very large and really unlocks the potential of the Landsat archive for users to start looking at global change. So it spans 36 years to date from 1982, spans Landsats 4 through 8 for now, and that's the 30-meter pixel resolution era. And you can read the numbers for yourself, but all in all, the archive is growing every day, and so these numbers will continue to change. But right now, when this graphic was created a few months ago, there was over 230 terabytes of Landsat ARD data available for users to start downloading. So that leads to this grand challenge that the USGS is going to boldly take on, is how to analyze and visualize, once we get global ARD, this 45-year record of Landsat Analysis Ready Data. There's going to have lots and lots of tiles that span around the world, and this going back to 1972 if they do choose to open up that MSS era. There's going to be some very, very intricate ways of being able to interact with the data, do some analysis, and return some results so we can look at global change over time. So into the next topic, the Landsat Science Products. There are 4 of these products that will be released soon: surface temperature, dynamic surface water extent, burned area, and fractional snow-covered area. The big question we get is when these will be available to the public. Right now, they are all still in various stages of production, but I can tell you they are very close to becoming publicly available. We are shooting to have some of these available towards the end of this year, and then definitely they should be available in early 2019. So what is the surface temperature product? It's available across the United States from 1982 to present, and it's generated from ARD products, top of atmosphere reflectance, brightness temperature, and then we use the ASTA Global Emissivity Database and the ASTA NDVI as inputs to generate this product. If you download this, there are 9 products associated with this. Most users may just want to use the surface temperature, but for now we are also providing the other 8 products for advanced users who may want to look at emissivity, standard deviation, what the upweld and downweld radiation was in order to calculate the surface temperature. The next product is called Dynamic Surface Water Extent, again, only available across the United States for now. This is available from 1982 to present, and this is generated from surface reflectance, ARD, and the pixel quality assessment band. For this, there are 6 products available at 30-meter resolution, and these are listed here. And again, we provide the extra product layers for advanced users that may want to see how surface water was calculated, what the percent slope was, what the hill shade was at the time. The next product is burned area. This is only available across the lower 48 United States at this time. It's available from 1984 to present, and it was generated from ARD, surface reflectance, and also the pixel quality assessment. And what users will get with this is 2 products, the burn probability and the burn classification, and these are at 30-meter resolution. And the final product is called Fractional Snow-Covered Area. This is only available across the western U.S., primarily in the higher elevations, mountainous areas. This is available from 84 to present, or will be, generated from ARD top of atmosphere reflectance, surface reflectance, and pixel QA. And there's 2 acquisition-based products that will be available that will delineate fractional or identify fractional snow-covered area, and also a cloud mask in order for users to be able to see how snow cover was derived. There's also an additional product called Statistics Products, which provides the monthly fractions and what the cloud-free count was in order for the algorithm to compute that pixel as being classified as snow, and what the mean annual snow fraction for that pixel was as well. These are all provided to users depending on what kind of usage that they're being applied for. So not all of these products are necessarily used by every user. So switching gears, going to give you a little bit update on plans for the next series in the Landsat program, which is going to be launched, which is Landsat 9. This is in collaboration with the Kennedy Space Center, Goddard Space Flight Center, and where I work, EROS, and it's a collaborative partner with NASA and the USGS, which has been going on for quite some time. Landsat 9 maintains a launch readiness date of December 2020. Again, it'll be launched like Landsat 8 from California at Vandenberg Air Force Base. And the great thing for users is that it's basically a rebuild of Landsat 8. Not much is going to change at all. So we're going to maintain the operational land imager and the thermal infrared sensors that are currently on board Landsat 8, and just delineate those with a 2 at the end. It's going to assume Landsat 7's orbit and acquire about 730 scenes a day. There's a slight change in that it's going to move to an all-land acquisition strategy, and what that means that even small islands are also going to be acquired by Landsat 9. These previous small areas of land were only imaged if there was a special request submitted to the USGS and NASA to acquire imagery over those small sites. So basically what it means for users is there's going to be more data that's collected by Landsat 9. So once the spacecraft is launched, there'll be about a 60-day instrument acclimatization period where we'll do like an orbital checkout to make sure that the systems are all functioning normally. And we'll do an underfly with Landsat 8 to make sure that the operational land imager 2 is collaborated with operational land imager 1 on board Landsat 8. We get a lot of questions about what's going to happen to Landsat 7. It's definitely a workhorse and has been going strong since 1999. And I have an interesting slide shortly about the plans for Landsat 7. So back in October, ULA, United Launch Alliance, were awarded the contract to launch Landsat 9. Be on board an Atlas V rocket, again, like I said, from Vandenberg. And they've already performed, it's called a coupled load analysis, just to make sure that everything fits and that the ULA have the correct load estimates for designing the observatory that the instruments are going to be bolted to. And obviously, between now and launch, there's going to be routine integration and coordination between L9 and ULA. And you might see us post some relevant information to users on the Landsat mission's website and through our Twitter account as we build up to launch fever. Just a couple of milestones that have recently happened with the L9 mission development. In April, USGS and NASA completed what's called the L9 Mission Critical Design Review, where both sides of USGS and NASA come together and go through the details of the entire mission design, which is why it's called a Critical Design Review, and it passed with flying colors. So the targeted launch date of 2020 is still holding. In May of 2018, just recently, the Landsat 9 OLE-2 instrument focal plane integration occurred. OLE is being built by Ball Aerospace, and they were gracious enough to provide us some images of that taking place. So what does the timeline look like? This planning for Landsat 9 started in 2015, not long after launch of Landsat 8, believe it or not. And as you can see from this graphic, we're currently in the Phase C era, which is towards the middle to end of the development of the instruments and also spacecraft development. Next month, NASA and USGS will be getting together to discuss the DPAS, which is called the Data Processing and Active Archive System. So basically, the engineering behind receiving the data, processing it, and distributing it to the user. So they're going to go through the critical design review stage of how all that's looking and making sure that once data is received, it is processed, archived, and distributed to the users for them to be able to use. So what's happening with Landsat 7? It's going to be part of a NASA mission called the Restore-L mission. And this mission has 3 objectives. It's going to refuel a government-owned client satellite in low Earth orbit, which has been identified as Landsat 7 for now. It's basically going to be a technology demonstration mission to look at doing advanced robotic servicing to spacecraft that are already in orbit, should an anomaly occur. And with this mission, there is an option to service additional satellites if owners of those satellites approach the NASA Satellite Servicing Division to see if they could also do that. So in short, this robot will be launched. It will rendezvous with Landsat 7, which will have been moved into lower Earth orbit. And as the graphic on the right illustrates, there's going to be a robotic arm that will try and do an on-orbit refuel and see if this is even possible. So we will definitely be following this mission on our website and social media feed. Obviously, so will NASA. It'll be the first of its kind ever to be done. And right now, there's no finite window of when this will occur. Probably looking at post-2020 after Landsat 9 launch, because we're going to have to move Landsat 7 into a lower Earth orbit in order to achieve this capability. But it's very exciting. And finally, these are the data portals that you can use to access all Landsat products, Level 1, the Landsat ARD Level 2 product, and as soon as they are available, the Landsat Level 3 Science products will be available from Earth Explorer. NASA, our agency partner, also provide data pool options for you to access and download data. And just as a reminder, that all Landsat data is available at no charge to the user, no matter where you are in the world. And that concludes my presentation for today. I thank you, everybody, for joining us. This is our information. If you do have any more questions about the program, don't hesitate to contact me. We also have various methods of you being able to stay in contact with us. We have the Landsat Missions website. We also have a Twitter account and Facebook account that we run in conjunction with our agency partners, NASA. There's also a YouTube account, video library, where we'll upload some videos about the use of Landsat products, and interviewing Landsat Science team members on their research. And there's also Landsat updates and Landsat headlines RSS feeds that you can subscribe to. A Landsat update is about a quarterly newsletter that we send out to subscribers about latest news about the Landsat program, data access and new products that are coming out, or if there's any changes to the data product that we're delivering. And thank you very much for your time.
Okay, well at this point what we're going to do is we'll actually transition to a final set of polling questions, and then from there we will move to the Q&A period, just similarly as we would with our NASA Earth Data webinars. So let's give these questions 3 to 4 minutes or so, and then from there we'll move to the Q&A period. So stay around on the line if you would like to ask a question and have those questions answered. All right, thanks everybody. Okay, everybody, we're going to give these questions just another minute or so, and then from there we'll move to the question and answer period. Okay, everybody, I think at this point in time we will transition to our Q&A period. So let me pull that up really quickly. We did have a question a bit earlier on. If you think of something, please type that into the Q&A pod, and it works like a chat. Okay, so our first question was, I would like to ask if there is any radar data like RISAT or RadarSat freely available like Landsat data for academic purposes, particularly for Indo-Gangetic Basin. And so there was additional specification, Chris, and that was that they were looking for USGS free data, SAR data, C-band strips available for India. I guess they're looking for any radar data, if that is available from USGS. Could you elaborate on that?
Yeah, absolutely. I'm not too familiar with the radar instruments that are out there, and I don't know what USGS holdings have. The user is more than happy to email me their question at that email that's on the screen, and we can look at if we have any in our data repositories that may be able to be distributed freely. But yeah, I'm not familiar with any radar data holdings at USGS off the top of my head, but we can certainly find that out.
Yes, and so I did respond to the user that NASA's Alaska Satellite Facility, DAC, in Fairbanks, Alaska, does have a number of different synthetic aperture radar, including C-band data products freely available through their Vertex search engine. And so that website is www.asf.alaska.edu, so that's also a potential source. And this does include, through an agreement with the European Space Agency, the Sentinel-1, Sentinel-1A, and the Sentinel-1B data products as well. Hopefully that's helpful. Okay, so the next is more of a comment that this user is looking forward to getting ARD data in other areas outside the U.S.
Yes, and we will definitely keep users informed of when global ARD is going to be available, and we will see if the USGS would like to provide sample products, so users don't have to wait so long. But that will be TBD. Again, we will keep all this information up to date on the Landsat website, our Twitter accounts, and through the Landsat updates would be a good place for people to subscribe to learn more about the development of global ARD and any other Landsat products that will be coming out in the future.
Okay, thank you, Chris. Our next question is, any idea whether Landsat ARD products will be available in Google Earth Engine or other cloud-based processing environments?
That's a great question. With the volume of data, people are looking more to cloud servicing solutions. Right now, I don't know what Google's plans are if they are already ingesting ARD. I'm not familiar with that. But there is the LPDAC, NASA LPDAC, just ingested ARD into their Appears interface, and that's publicly available for users. So I can provide that URL to the user if they want to access ARD in this Appears interface.
Okay, great, thank you. So the next question is, what is the accuracy of georeferenced product?
That's a great question. There's multiple ways you can look at that. But so the collections are are based on this root mean square error. So that's kind of what we use to help bin them into either the Tier 1 or the Tier 2 category. So if that's kind of the angle that the user's coming from, it's hard to say, but that 12-meter RMSE is kind of the error. It's basically less than half a pixel width, so 30-meter pixel resolution. So that's kind of the angle the user's coming from. It's less than half of a pixel offset in the tier category designation.
Okay, thank you, Chris. And just as we're waiting for additional questions, I would be remiss if I didn't also mention that you can find quite a few data recipes and Earth Science Data Discovery and Access webinars at the NASA Earth Data YouTube channel, including an older Landsat webinar, which is still pretty frequently accessed even today. That's from, I think, 2014. And then there's a SAR webinar for the user who inquired about sources for synthetic aperture radar data. So that might be something you'd like to check out. Let's see here. Are there any additional questions? Okay, let's see here. The next question, Chris, is would there be any training program on Landsat ARD for the beginner level users?
The best I can say right now is we are going to plan on making a series of videos to kind of help familiarize users with ARD and how you download it, how you would use it in an application. We are working on developing little tutorials like that, little videos. But if they're asking for if there's any like formal workshops on ARD, there is none that I think are planned at this time. But it's probably possibly something that we could consider in the future if there's enough of a demand for that.
Okay, thank you. Are there additional questions here? Let me take a look. Okay, while we're waiting, the presentation files along with the agenda and the animated GIFs that showed the Landsat orbit are available for download in the lower right-hand corner of your screen. If you highlight any of these files, you'll be prompted with an option to download those files. What we'll do if there are no further questions, we'll leave the virtual meeting space open an additional 10 minutes or so. However, we will log off from the audio component. You'll no longer be able to hear us, but certainly if you think of something in the meanwhile during those 10 minutes, please feel free to type those into the Q&A pod, and I will forward that log along to our speaker today who will be able to address those inquiries offline. All right, so let's take a look and see. All right, well, thanks, everybody. Are there any additional questions? Going once. Going twice. Let's see here. Yes, so the slides are available in the lower right-hand corner, and but I have them available as a PDF. I suspect you could probably email Chris directly if you would like the PowerPoint version for the slides today. They were a bit too large for sharing in the file share pod within the Adobe Connect application. I hope that helps a bit. I'd like to thank our speaker today, and I'd like to thank all of you for participating in today's webinar. Let me make sure I've got, I'm glad that we're getting some really good feedback that you enjoyed today's presentation. As part of our NASA Earth Data webinar series, our next webinar will be held on July 25th, and we'll focus on how to discover and access NASA's IceBridge data just from an airborne campaign. If that is something that interests you, you can find out information by going to tinyurl.com/earthdatawebinar in the weeks to come. All right, well, thanks, everybody.
Thanks, Jennifer. I want to thank you and NASA for hosting us today, and thanks everybody that participated. You can reach me on that email, or with USGS also has a user services email that you can email questions about Landsat products or any USGS product, and that is cusserve@usgs.gov. Thank you very much.
Okay, thank you, Chris. At this point, we will log off from the audio component, and perhaps we will see some of you at an upcoming webinar. All right, take care. Bye-bye now.